This episode is looking at factorizing the difference of two squares. So recall that a difference of two squares is formed when expanding the product of the sum and the difference of two terms. So for example, here we have x plus 2, which is the sum of two terms, and x minus 2, which is the difference of two terms. So that's the difference of two squares. Reversing this process means that a difference of two squares can be factorized into two binomial expressions of the form a plus b and a minus b. So in this particular case, you would be looking to get it from x squared minus 4 back into the binomial terms. So that is the factorization process. And then expansion is going that way. Today we're looking at the factorizing. So factorizing the difference of two squares uses a rule, and you need to ensure that you are working to go with a squared minus b squared is going to go back into the form of a plus b, a minus b. Okay, so a times a gives you a squared, b times b gives you b squared, and then when you multiply a positive with a negative, you're going to get a negative. If we were to have two positives in the brackets, then that'll be a perfect square. You're going to have a positive there, and likewise, if you had negative and a negative, you're still going to get a positive. So that's not going to give you that form. So we're looking for a difference of two squares. When you see a subtraction between the two squared terms, then you know it's going to be a plus b and then a minus b. So with our first example, we'll start off nice and easy. We have x squared minus 16. Now that's quite simple. We know that that is in the form of x squared minus 4 squared. So there we have simplified the 16. We've square rooted the 16 and take that as the squared form of 4. And now that we have this picture of x squared minus 4 squared, that matches our rule, a squared minus b squared. So we know that we can just go, well, our a is our x plus our b, and then our a minus our b, and that's it, done. When we get a little bit more complicated,